Get your swim trunks on, my darling. We have 20,000 Leagues Under the Sea, Chapter 12. Some figures. A moment after we were seated on a divan in the saloon smoking, the captain showed me a sketch that gave me the plan, section, and elevation of the Nautilus. Then he began his description in these words. Here, Monsieur Anorax, are the several dimensions of the boat you are in. It is an elongated cylinder with conical ends. It is very like a cigar in shape, a shape already adopted in London in several constructions of the same sort. The length of the cylinder from stem to stern is exactly 232 feet, and its maximum breadth is 26 feet. It is not built quite like your long voyage steamers, but its lines are sufficiently long and its curves prolonged enough to allow the water to slide off easily and oppose no obstacle to its passage. These two dimensions enable you to obtain, by a simple calculation, the surface and cubic content of the Nautilus. Its area measures 6,032 feet, and its contents about 1,500 cubic yards. That is to say, when completely immersed, it displaces 50,000 feet of water, or weighs 1,500 tons. When I made the plans for this submarine vessel, I meant that 9/10 should be submerged. Consequently, it ought only to displace 9/10 of its bulk. That is to say, to weigh that number of tons. I ought not, therefore, to have exceeded that weight, constructing it on the aforementioned dimensions. The Nautilus is composed of two hulls, one inside, the other outside, joined by T-shape irons, which render it very strong. Indeed, owing to this cellular arrangement, it resists like a block, as if it were solid. Its sides cannot yield. It coheres spontaneously, and not by the closeness of its rivets. And the homogeneity of its construction, due to the perfect union of the materials, enables it to defy the roughest seas. These two hulls are composed of steel plates, whose density is from 0.7 to 0.8 that of water. The first is not less than 2 inches and a half thick and weight 394 tons. The second envelope, the keel, 20 inches high and 10 thick, weighs alone 62 tons. The engine, the ballast, and several accessories and apparatus appendages, the partitions and the bulkheads weigh 961.62 tons. Do you follow all of this? I do. Then, when the Nautilus is afloat under these circumstances, 1/10 is out of the water. Now, if I have made reservoirs of a size equal to this 10th, or capable of holding 150 tons, and if I fill them with water, the boat, weighing then 1,507 tons, will be completely immersed. That would happen, Professor. These reservoirs are in the lower part of the Nautilus. I turn on taps and they fill, and the vessel sinks. That had just been level with the surface. Well, Captain, but now we come to the real difficulty. I can understand your rising to the surface, but diving below the surface? Does not your submarine contrivance encounter a pressure and consequently undergo an upward thrust of 1 atmosphere for every 30 feet of water, just about 15 pounds per square inch? Just so, sir. Then, unless you quite fill the Nautilus, I do not see how you can draw it down to those depths. Professor, you must not confound statistics with dynamics, or you will be exposed to grave errors. There is very little labor spent in attaining the lower regions of the ocean, for all bodies have a tendency to sink. When I wanted to find out the necessary increase of the weight required to sink the Nautilus, I had only to calculate the reduction of volume that the seawater acquires according to the depth. That is evident. Now, if water is not absolutely incompressible, it is at least compatible of very slight compression. Indeed, after the most recent calculations, this reduction is only 0.000436 of an atmosphere for each 30 feet of depth. If we want to sink to 3,000 feet, I should keep accounts of the reduction of bulk under a pressure equal to that of a column of water of 1,000 feet. The calculation is easily verified. Now I have supplementary reservoirs capable of holding 100 tons. Therefore, I can sink to a considerable depth. When I wish to rise to the level of the sea, I only let off the water and empty all of the reservoirs if I want the Nautilus to emerge from the 10th part of her total capacity. I had nothing to object to these reasonings. I admit your calculations, Captain, I replied. I should be wrong to dispute them since daily experience confirms them, but I foresee a real difficulty in that way. What, sir? When you are about 1,000 feet deep, the walls of the Nautilus bear a pressure of 100 atmospheres. If then, just now you were to empty the supplementary reservoirs to lighten the vessel and to go up to the surface, the pumps must overcome the pressure of 100 atmospheres, which is 1,500 pounds per square inch. From that a power that electricity alone can give, said the captain hastily. I repeat, sir, that the dynamic power of my engines is almost infinite. The pumps of the Nautilus have an enormous power, as you must have observed when their jets of water burst like a torrent upon the Abraham Lincoln. Besides, I use subsidiary reservoirs only to obtain a mean depth of 750 to 1,000 fathoms, and that with a view of managing my machines. Also, when I have a mind to visit the depths of the ocean, 5 or 6 miles below the surface, I make use of slower, but not less infallible means. What are they, Captain? That involves my telling you how the Nautilus is worked. I'm impatient to learn. To steer this boat to starboard or port, to turn, in a word, following a horizontal plan, I use an ordinary rudder fixed to the back of the stern post, with one wheel and some tackle to steer by. But I can also make the Nautilus rise and sink and rise by a vertical movement by means of 2 inclined planes fastened to its side, opposite the center of flotation, planes that move in every direction and that are worked by powerful levers from the interior. If the planes are kept parallel with the boat, it moves horizontally. If slanted, the Nautilus, according to this inclination and under the influence of the screw, either sinks diagonally or rises diagonally as it suits me. And even if I wish to rise more quickly to the surface, I shift the screw, and the pressure of the water causes the Nautilus to rise vertically like a balloon filled with hydrogen. Bravo, Captain! But how can the steersman know the route in the middle of the waters? The steersman is placed in a glazed box that is raised about the hull of the Nautilus and furnished with lenses. Are these lenses capable of resisting such pressures? Perfectly. Glass, which breaks at a blow, is nevertheless capable of offering considerable resistance. During some experiments of fishing by electric light in 1864 in the northern seas, we saw plates less than 1/3 of an inch thick resist a pressure of 16 atmospheres. Now, the glass that I use is not less than 30 times thicker. Granted, but after all, in order to see, the light must exceed the darkness. And in the midst of the darkness in the water, how can you see? Behind the steersman's cage is placed a powerful electric reflector, the rays of which light up the sea for half a mile in front. Ah, bravo, bravo, Captain! Now I can account for this phosphorescence in the supposed narwhal that puzzled us so. Now I ask you, in the boarding of the Nautilus and of the Scotia, that has made such a noise has been the result of a chance rencontre. Quite accidental, sir. I was sailing only 1 fathom below the surface of the water when the shock came. It had no bad results. None, sir? But now, about your reconnoiter with the Abraham Lincoln. Professor, I am sorry for one of the best vessels in the American Navy, but they attacked me, and I was bound to defend myself. I contented myself, however, with putting the frigate hors de combat. She will not have any difficulty in getting repaired at the next port. Ah, Commander, your Nautilus is certainly a marvelous boat. Yes, Professor, and I love it as if it were part of myself. If danger threatens one of your vessels on the ocean, the first impression is the feeling of an abyss above and below. On the Nautilus, men's hearts never fail them. No defects to be afraid of, for the double shell is as firm as iron. No rigging to attend to, no sails for the wind to carry away, no boilers to burst, no fire to fear, for the vessel is made of iron, not wood. No coal to run short, for electricity is the only mechanical agent. No collision to fear, for it alone swims in deep water. No tempest to brave, for when it dives below the water, it reaches absolute tranquility. There, sir, that is the perfection of vessels, and if it is true that the engineer has more confidence in the vessel than the builder, and the builder than the captain himself, you understand the trust I repose in my Nautilus. For I am at once captain, builder, and engineer. But how could you construct this wonderful Nautilus in secret? Each separate portion, Monsieur Anorak, was brought from different parts of the globe. The keel was forged at Creusot, the shaft of the screw at Pen & Co., London, the iron plates of the hull at Laird's of Liverpool, the screw itself at Scott's at Glasgow. The reservoirs were made by Cale & Company at Paris, the engine by Krupp in Prussia, its beak in Motala's workshop in Sweden, its mathematical instruments by Hart Brothers of New York, etc. And each of these people had my orders under different names. But these parts had to be put together and arranged. Professor, I had set up my workshop upon a desert island in the ocean. There my workmen, that is to say, the brave man that I instructed and educated, and myself have put together our Nautilus. Then when the work was finished, fire destroyed all trace of our proceedings on this island, that I could have jumped over if I had liked. Then the cost of this vessel is great. Monsieur Anorak, an iron vessel costs 45 pounds per ton. Now the Nautilus weighs 1,500. It came therefore to 67,500 and 80,000 more for fitting it up. About 200,000 pounds with the works of art and the collection it contains. Can't get a house for that. One last question, Captain Nemo. Ask it, Professor. Are you rich? Immensely rich, sir, and I could, without missing it, pay the national debt of France. I stared at the singular person who spoke thus. Was he playing upon my credulity? The future would decide this. Well, that was a lot of information and no plot forward, but tell you what, my darlings, we'll do chapter 13 too. Why not? Chapter 13, The Black River. The portion of this terrestrial globe which is covered by water is estimated at upwards of 80 millions of acres. This fluid mass comprised 2,250 millions of cubic miles, forming a spherical body of a diameter of 60 leagues, the weight of which would be 3 quintillions of tons. To comprehend the meaning of these figures, it is necessary to observe that a quintillion is to a billion as a billion is to a unity, In other words, there are as many billions in a quintillion as there are units in a billion. This mass of fluid is equal to about the quantity of water which would be discharged by all of the rivers of the earth in 40,000 years. During the geological epochs, the igneous period succeeded to the aqueous. The ocean originally prevailed everywhere. Then by degrees, in the Silurian period, the tops of the mountains began to appear, and the islands emerged, then disappeared in partial deluges, reappeared, became settled, formed continents, till at length the earth became geographically arranged, as we see it in the present day. The solid had wrested from the liquid 37,657 square miles, equal to 12,960,000,000 of acres. The shape of continents allows us to divide the water into 5 great portions: the Arctic, or frozen ocean, the Antarctic, or frozen ocean, the Indian, the Atlantic, and the Pacific. The Pacific Ocean extends from north to south between the 2 polar circles and from east to west between Asia and America. Over an extent of 145 degrees of longitude is the quietest of the seas. Its currents are broad and slow. It has medium tides and abundant rain. Such was the ocean that my fate destined me first to travel over under these strange conditions. "Sir," said Captain Nemo, "we will, if you please, take our bearings and fix the starting point of this voyage. It is 11:45. I will go up again to the surface." The captain pressed an electric clock 3 times. The pumps began to drive the water from the tanks. The needle of the manometer marked by a different pressure the ascent of the Nautilus, and then it stopped. "We have arrived," said the captain. I went to the central staircase, which opened onto the platform, clambered up the iron steps, and found myself on the upper part of the Nautilus. The platform was only 3 feet out of the water. The front and back of the Nautilus was of that spindle shape, which caused it justly to be compared to a cigar. I noticed that its iron plates slightly overlaid each other, resembling the shell which clothes the bodies of our large terrestrial reptiles. It explained to me how natural it was, in spite of all glasses, that this boat should have been taken for a marine animal. Towards the middle of the platform, the longboat, half buried in the hull of the vessel, formed a slight excrescence. Fore and aft rose 2 cages of medium height with inclined sides, and partially closed by thick lenticular glasses. One destined for the steersman who directed the Nautilus, the other contained a brilliant lantern to give light on the road. The sea was beautiful, the sky pure. Scarcely could the long vehicle feel the broad undulations of the ocean. A light breeze from the east rippled the surface of the waters. The horizon, free from fog, made observation easy. Nothing was in sight. Not a quicksand, not an island, a vast desert. Captain Nemo, by the help of his sextant, took the altitude of the sun, which ought to give the latitude. He waited for some moments till its disk touched the horizon. While taking observations, not a muscle moved. The instrument could not have been more motionless in the hand of marble. 12 o'clock, sir," he said. "When you like." I cast a long look upon the sea, slightly yellowed by the Japanese coast, and descended to the saloon. "And now, sir, I leave you to your studies," added the captain. "Our course is ENE. Our depth is 26 fathoms. Here are maps on a large scale by which you may follow it. The saloon is at your disposal, and with your permission, I will retire." Captain Nemo bowed, and I remained alone, lost in the thoughts all bearing on the commander of the Nautilus. For a whole hour I was deep in these reflections, seeking to pierce this mystery so interesting to me. Then my eyes fell upon the vast planisphere spread upon the table, and I pressed my finger on the very spot where the given latitude and longitude crossed. The sea has its large rivers like continents. They are special currents known by their temperature and their color. The most remarkable of these is known by the name of the Gulf Stream. Science has decided on the globe the direction of 5 principal currents, one in the North Atlantic, a second in the South, a third in the North Pacific, and a fourth in the South, and a fifth in the Southern Indian Ocean. It is even probable that a 6th current exists at one time or another in the Northern Indian Ocean when the Caspian and the Aral Seas formed but one vast sheet of water. At this point, indicated on the planisphere, one of these currents was rolling, the Kuro-Skivo of the Japanese, the Black River, which, leaving the Gulf of Bengal, where it is warmed by the perpendicular rays of a tropical sun, crosses the Strait of Malacca along the coast of Asia, turns to the North Pacific, to the Aleutian Islands, carrying with it trunks of camphor trees and other indigenous products, and edging the waves of the ocean with the pure indigo of its warm water. It was this current that the Nautilus was to follow. I followed it with my eyes, saw it lose itself in the vastness of the Pacific,